Alright, hopefully this is the last part of section 3.2. It starts off with similar questions to the first part. The big difference in the parts 37 through 48 than the last few problems that we did is there's a number in the parentheses instead of a letter, and that makes it actually quite a bit easier. So what I ultimately am going to need to do for each one of these problems is take the number that's in the parentheses and plug it in for the appropriate x's. To get started for each of the problems between number 37 and 48, first I want to create a non-simplified version of the answer of the problem if the problem was written with an x. I don't think I can spell unsimplified, and I'm not sure that it's a word. But I want to create an unsimplified version of the problem that has an x in the parentheses as opposed to a number. So for problem 38, the first thing that I would like to do is create an unsimplified version of the problem, but changing that number that was in the parentheses to an x. And this is super easy to do. I'm just going to put a parentheses for the x, for the h, and a parentheses for the k. In the h parentheses, I'm going to put in an x squared plus 2x plus 1. And for the k parentheses, I'm going to put a 2x minus 5. I did the h first and the k second. This I would consider an unsimplified version of the problem that has an x in the parentheses in that parentheses. And now, second, I'm going to change the x back to the original number, and simplify to get my answer. So the initial problem 38 didn't have an x in the parentheses. It had a negative 1 in the parentheses. And now I know where I need to place that negative 1. I need to place the negative 1 into all these x's. So h times k of negative 1 is going to equal negative 1 squared plus 2 times negative 1 plus 1, and then 2 times negative 1 minus 5. I think I'm going to be pretty lazy this morning and do a lot of these on my calculator. So I'm going to attempt to enter this on my calculator. I'm going to go first parentheses, and then negative 1 squared in a parentheses, plus 2 parentheses negative 1, and then plus 1, and then that right parentheses, and then the left parentheses, and then 2 parentheses negative 1, minus 5 in that right parentheses. My answer to this, is going to be h times k of negative 1 equals to 0. It would be wrong to say x equal to 0 for my answer, because x is actually equal to negative 1. It would be okay to say y equal to 0 for my answer. Slow start this morning. But that's probably the best answer for this problem. If you just for an answer wrote the number 0, that would be okay. If you really wanted to do this by hand, you certainly can. To do this by hand to get to that answer, the first parentheses, the negative 1 squared is a positive 1. The 2 times negative 1 is a negative 2. So I'd get 1 plus negative 2, and then I'd have this plus 1. The last parentheses, 2 times negative 1 is negative 2, and you'd get negative 5. This right here 1 plus negative 2 is negative 1 plus 1 is 0. So if I was simplifying this by hand, the first parentheses would come out to 0. The second parentheses would come out to negative 7. And 0 times negative 7 is 0. I make a lot of silly math errors when I try to do things in my head when I'm making these videos, which causes me to reshoot a lot of videos. So I'm going to do a lot of the work on my calculator to get from the point where I'm plugging the number in for x to the answer and avoiding the potentials of making ridiculous math errors that I need to fix. I'm going to do a lot of work on my calculator. If I do the problems both by hand and on my calculator, then it gets to be ridiculously long. Not that it's already not ridiculously long. So I'm going to move on to try 37. I'm going to move on to 40. For each of these problems between 37 and 48, the first thing I'm going to do is create a version of the problem without the number in the parentheses and replace that number with an x. So as I go to do problem 40, the first thing I'm going to do is create an unsimplified version of the problem, changing the number in the parentheses to an x. And just like I did in problem 38, I put an equal sign followed by two parentheses. In the last problem, the two parentheses didn't have a sign between them because there was multiplication in the original problem. Put a minus sign in this because of the minus sign in the original problem. In the first parentheses, I need to put in something to represent k, and that's going to be 2x minus 5. In the second parentheses, I need to put in something to represent the h of x, and that's going to be x squared plus 2x plus 1. Now I have a place to plug this 0, so the next step I'm going to do is I'm going to change the x back to 0, and I'm going to simplify and go 2 times 0 minus 5 minus 0 squared plus 2 times 0 plus 1. I feel like I can do this by hand quickly, but I'm not gonna. I'm just going to do this on my calculator now to be safe. My calculator is going to need a boatload of parentheses, but I'm just going to enter this left to right just like I see it. So left parentheses 2, parentheses 0, close out the parentheses, minus 5, close out that parentheses. There's the first one. Then a minus sign, and then parentheses, and then 0 in a squared in a parentheses, plus 2 parentheses 0 plus 1. Close out that parentheses. This looks just like that. When I hit enter, that should give me my answer of negative 6. So this will be my answer to problem 40. And that's all I'll show. When you go to do 39, you won't really need parentheses. When you get started with problem 39, the first thing you're going to write is h divided by k of x. And to the right of the equal sign, you're going to put a fraction. You don't really have to have parentheses, but if you want to, you could put a parentheses in the numerator as well as a parentheses in the denominator. In the numerator, you're going to put something to represent the h function, which is going to be x squared plus 2x plus 1. In the denominator, you're going to put something to represent the k function, which is 2x minus 5. And then you're going to change the x to 5 and simplify. You really don't have to put the parentheses around the entire numerator nor around the entire denominator. So I probably wouldn't. On this line I put the unneeded parentheses, and here I drop the parentheses, and then you just have to simplify this. The answer is likely a fraction, and I'd rather have a fraction answer than a decimal. Let me do 41, just because 42 is a multiplication. I've already done a multiplication. So let me do 41, because it's just generally harder, I think. So for 41, I want to first change that 7 to an x and do h minus k of x. Put an equal sign, and on either side of my equal sign, put parentheses. The only time I really don't need parentheses is with division. In the first parentheses, I'm going to put something to represent the h, which is the x squared plus 2x plus 1. In the second parentheses, I'm going to put something to represent the k, which is 2x minus 5. If I wanted to, I could clear the parentheses and combine like terms, but that's just doing more work than I have to. Once I get an unsimplified version with the x, I can change the x back to a number and plug that number in for x and simplify. So now I'm changing each of the x's to 7s. I'm about ready to write my answer for problem 41. I'm going to write h minus k of 7 equals, and I'm going to just go about figuring out what it equals to. So I'm going to just enter this on my calculator. So I'm going to go left parentheses and then 7 squared in a parentheses plus 2 parentheses 7 plus 1. Close out the parentheses, do a minus sign. Parentheses 2 parentheses 7 minus 5, close out my parentheses. Assume I did that right. I get for an answer 55. So for problem number 41, your answer should be h minus k of 7 equals to 55. Just make sure I didn't mess up. This is 49 plus 14 plus 1. That's 64. And this one is 14 minus 5. That's 9. I get 64 minus 9, which is 55. All right. The next two problems have composition, which makes them a little bit tougher, but I'm going to start them the same way. As I go to do problem 44, I'm going to find an unsimplified version of the problem, changing the number in the parentheses to an x, and this is composition of functions, which is a little bit harder. H composed with k of x means h of k of x. To find h of k of x, I'm going to take that x and change it to a k of x, because when you have h followed by a parentheses, whatever in that parentheses is what the x's get changed to. So this is going to be k of x squared, changing that x to a k of x, plus 2 times k of x, changing that x to a k of x, and then this plus 1 that kind of doesn't fit. So this is my start at this, but it's not good enough to get to an answer, specifically because that k of x is just yucky. So I'm going to change these k of x's now to 2x's minus 5. So I'm going to this line right there, and for each of the k of x's, for that k of x and that k of x, I'm going to change the k of x's to what they're equal to. And what k of x is equal to is 2x minus 5. So instead of writing k of x squared, I write 2x minus 5 squared, and then plus 2 times k of x. Instead of that k of x, I put 2x minus 5. And I have this plus 1. This is an unsimplified version of h composed with k of x that I now can change to h composed with k of 0. And I can plug the number in for x, in this case 0 in for x, and simplify. So all I'm doing from this line to that line is taking those two x's and changing them to 0. So it's 25, 15, I think this is 16. I'm going to do it on my calculator to be safe, assuming I'm awake enough to do this. I think that's the right answer, but let me just do this on my calculator. I'm going to enter it as close as I can to just like that. So parentheses 2 parentheses 0 minus 5 parentheses squared plus 2 parentheses 0 minus 5 plus 1, and I get 16. So that's perfect for that. So 43 should work similarly. Let me do 45 on this page as opposed to 46, just to give one of your problems a go. So to start on problem 45, the first thing I want to do is find an unsimplified version of k composed with h of x. I know that k composed with h of x as k of h of x. That means to go to the k function and change that x to an h of x. So this is going to be 2 times h of x minus 5. And now on the next line, I'm going to change that h of x to x squared plus 2x plus 1. So this is going to change to that. And I'm going to get 2 parentheses, instead of the h of x squared plus 2x plus 1, and then the minus 5. This is an unsimplified version with the x, and now I need to deal with the number in the problem, which is 3. I'm going to change the x to the number 3 on the left-hand side and change those x's on the right-hand side to 3 as well. So I'll get 2 times 3 squared plus 2 times 3 plus 1 minus 5, 9, 15, 16. I think this is 27. And just to be safe, I'm just doing all the work on my calculator because it's a lot easier. Or it's a lot, well, maybe not necessarily easier, but more accurate. So 2 parentheses, 3 squared plus 2 parentheses 3 plus 1 parentheses, and then minus 5. And I get 27. So the danger of doing it by hand. Let me make sure that that's okay. This is 2 times 9 plus 6 plus 1 minus 5. This is 2 times 16 minus 5, and that's 32 minus 5, which is 27. So the answer should be 27. When we go to do problems 47 and 48, 47 and 48 start off with k composed with h, and then they have numbers, different numbers in the parentheses. The first step in problem 48, when I go to do it, is to find an unsimplified version of k composed with h of x. And I just did that on the last problem, so I'm not going to redo that work. I'm going to borrow from my last problem, as you should when you go to do problem 47. Since I've already figured out an unsimplified version of k composed with h of x, I'm going to use that for my first step rather than going through the few bits of algebra to get there. And then I'm going to change the x back to the number that's in the parentheses on both sides of the equation. And this will take me straight to my answer a lot quicker. So I took my unsimplified version of k composed with h of x. Now I'm changing the x's to -6, and I'm just going to break out my calculator and go 2 parentheses and then -6 squared in a parentheses plus 2 parentheses -6 plus 1, close out my parentheses, minus 5. And I get for an answer k composed with h of -6 equals to 45. Alright, so your 47 should work the same way. The next group of problems, 49 through 57, aren't really any different other than they have different letters with slightly different values. So as I go to do problem 50, problem 50 wants me to find s minus t of 4. It doesn't matter that I change these letters. When I go to do problem 50, the first thing I want to do is change the number in a parentheses to an x, and find an unsimplified version of that, which I didn't really leave myself enough room, so I'm going to redo that. So to do 50, the first thing I do is take the number in the parentheses, change it to an x, and then I set myself up. I write an equal sign. After the equal sign, I make one parentheses for the s, a second for the t with a minus between them. In the s parentheses, I'm going to put x squared plus 5x minus 3. Into the t parentheses, I'm going to put 2x minus 7. And now I'm going to change the number back to what it's supposed to be. In this case, it's supposed to be a 4. And onto the right side of the equal sign, I'm going to change each of those x's to a 4. I'm going to get 4 squared plus 5 times 4 minus 3 minus 2 times 4 minus 7, 16, 36, 33 minus 1. I think this is 32. But I'm going to do every one of these on my calculator because it's just not that hard to do, and it's not going to make a mistake. At least I'm not as likely to make a mistake. So parentheses, 4 squared plus 5 parentheses plus 4 parentheses 4 minus 3 parentheses minus parentheses 2 parentheses 4 minus 7, enter, and it is 32. So I feel real good about that. I have 2 problems for you to do. For 49, when you get started on 49, you're going to start off figuring out what s divided by t of x is. And for fractions or division, you don't need parentheses. In the numerator, you're going to write something for the s, which is x squared plus 5x minus 3. In the denominator, you're going to write a 2x minus 7. And then for your second step on 49, you're going to change the x's to 3's on both sides of the equation, and you're going to get 3 squared plus 5 times 3 minus 3 over 2 times 3 minus 7, and then you just simplify that. 51 will work a lot like my 50. I'll move on to the next page, and we get in succession a couple s composed with t. So when I finish up problem 52 and move on to the next page, I'm going to borrow my first step. The first step on problems 52 and 53 is the same as the first step on 54 and 55. So I'll do 52 first. And as I go to do 52, the first step is to change that 4 to an x and find an unsimplified version of s composed with t of x. That means s of t of x, which means in the s function, I need to change that x and that x to a t of x. So that's going to be t of x squared, changing that x to a t of x, plus 5 times t of x minus 3. And now I'm going to change those t of x's to 2x minus 7. So I'm going to get s composed with t of x equals, that t of x is going to go to 2x minus 7, which is going to be 2x minus 7 squared. That t of x is going to go to 2x minus 7. So I get plus 5 times 2x minus 7, and then minus 3. Now I'm going to change the number in the parentheses to a 4 and get ready to get my calculator going. So I'll go s composed with t of 4 is going to be 2 times 4 minus 7 squared plus 5 times 2 times 4 minus 7 minus 3. And I'm just going to let my calculator do that work for me. So on my calculator, parentheses 2 parentheses 4 minus 7 squared plus parentheses, I forgot the 5, plus 5 parentheses 2 parentheses 4 minus 7 minus 3. And I get 3 for the answer. So my answer for problem 52, s composed with t of 4 equals to 3. When we move on to the next page and try to do 54 and 55, my first step is to find an unsimplified version of s composed with t of x. Let me go ahead and do 55 for you. And on the first step of 55, I change the number in the parentheses to an x and figure out an unsimplified version of s composed with t of x. Because I just did that, I don't need to do it again. I'm borrowing from my last sheet of paper. That's an unsimplified version with an x instead of the number. And now I can change that number back to what the x back to the number it's supposed to be, which is negative 2. If I do it on the left side of the parentheses, I need to do it on the right side of the parentheses. And what I'm going to enter on my calculator is 2 times negative 2 minus 7 squared plus 5 times 2 times negative 2 minus 7 minus 3. And then ultimately, for my answer, I'm going to write s composed with t of negative 2 equals, and whatever number that equals to, I'll throw down for my answer. So, yuck. On my calculator, I guess you don't need me to tell you what I'm typing in. You can see it, and hopefully you can do these on your calculator by now. It looks good. So I think my answer is going to be s composed with t of negative 2 is negative 49. Make sure this is right. Negative 1. Wow. That doesn't feel right. Let me just make sure that that's actually, it just doesn't feel right at all. It can't be. Let me do it one more time. So, parentheses, 2 parentheses negative 2 minus 7 parentheses squared plus 5 parentheses 2 parentheses negative 2 minus 7 parentheses minus 3. 63 feels so much better. I don't know what I did wrong, but I tried to type without talking, and apparently I need to talk, which would make me really annoying on the test. Let me do this by hand really quick. This first parentheses is 4 minus 7, and that's going to be negative 3 squared. The second parentheses, this is negative 4 minus 7, my lord. Negative 4 minus 7, the first parentheses should be negative 11 squared. The second parentheses has the same negative 4 minus 7, so it's going to be plus 5 times negative 11, and then minus 3. This is going to be 121, which is negative 11 squared, plus negative 55 minus 3. And 121 plus negative 55 minus 3 is 63. So 63 really is the answer. I'm not sure what I did wrong. As I watch the video, I'll see what I did wrong, but I fixed that mistake. 57 and 56 want me to find t composed with s. First step on 56 is to do t composed with s of x. I know that that means that equals t of s of x, which tells me to change that x to an s of x. So this is going to be 2 times s of x minus 7. Need to change that s of x to x squared plus 5x minus 3. So the first step for my 56 is the same as the first step for your 57. I'm finding an unsimplified version of t composed with s of x. I changed in the t function the x to an s of x. Now I'm going to change that s of x to x squared plus 5x minus 3. Now I can change the x back to a number and make this 2 times parentheses 1 squared plus 5 times 1 minus 3 minus 7. Oh gosh, this is 2, 3, 6. Thing comes out to negative 1. I think my answer is going to be t composed with s of 1 equals negative 1. Let me double check to make sure I haven't led myself wrong. So 2 parentheses, parentheses, 1 squared plus 5 parentheses, 1 minus 3 parentheses minus 7, and I get negative 1, so that's perfect. First step on your 57 is going to be the same as my first step, and all you're going to need to do is change that x and those two x's to negative 6 and simplify. Done with this kind of problem, moving on to the last kind of problems. I always put this kind of problem on a test. It says find the difference quotient, and the reason I always put these on a test over this chapter is because in about the first week or maybe the second week of any regular calculus, Math 220, or brief calculus, Math 212, you have to do this a bunch of times. So the difference quotient is a fraction, and in the numerator it has function symbols that need to be replaced with something that's not a function symbol, and the denominator has an h. So to figure out the difference quotient, I need to replace each function symbol in the numerator with something that's more appropriate. So I'm going to start off problem 58, and I'm going to say the difference quotient is make a fraction with a minus in the numerator, and on either side of that minus sign I'm going to put a parentheses. I'm going to leave the h in the denominator. So all I've done is I've replaced the function symbols with parentheses. The function symbol to the right of the minus sign in problem 58 can be replaced with 2x plus 6 because it says right up here f of x equals 2x plus 6. So as I go to do my transformation of the difference quotient into something that fits problem 58, I wrote the problem without function notation. I put parentheses where the function notation was. One of the two parentheses was easy to fill because I know exactly what f of x is. F of x is 2x plus 6. The other parentheses isn't as easy to do because I don't know what f of x plus h is, but it's not particularly hard to find f of x plus h. To find f of x plus h, I just take the x in the f function and change it to fx plus h. So f of x plus h is going to be 2 times x plus h plus 6. That's just changing that x to an x plus h. I could put that in this first parentheses, but let me clean this up a little bit by clearing the parentheses by multiplying 2 times x and getting 2x, and multiplying 2 times h and getting plus 2h. This is what I'm going to put in place of f of x plus h in the unused parentheses in the numerator. So I'm going to put a 2x plus 2h minus 6. This is an unsimplified version of this difference quotient, which is most of the way done. The only thing I need to do now is simplify the numerator by dropping the parentheses the correct way. The first parentheses I have in the numerator I can just drop without doing any sign changing. The second parentheses, because there's a minus in front of it, the minus is going to attach to go in front of that 2x and give me a minus 2x. And it's going to flip the sign in front of the 6. When you have a negative in front of a parentheses, that negative causes any signs deep in the parentheses to flip. Almost have my answer. I just need to combine like terms in the numerator. And if I look in my numerator, I see a 2x and a minus 2x. Those will cancel. And I see a negative... When I wrote this down here, there's a plus 6 here. I wrote a minus 6. This should be a plus 6. That should be a plus 6. As I'm watching the video later on, I'll notice that mistake, and at least I found it. So for whatever reason, I didn't copy this properly. That minus 6 is supposed to be a plus 6. There should be a plus 6 and a minus 6 that also cancel. What's left in the numerator that doesn't cancel is just a single 2h, and what's left in the denominator I haven't worked with yet is an h. This h, because it's multiplied by the 2, will cancel with the h in the denominator. It'll make the fraction go away, and my answer is going to be just the 2 that's left over. So my answer to problem 58 is just the single number 2. I could write the difference quotient as 2, or I can say, for an answer, if I want it to be really nice for number 58, if I didn't want to just write the number 2 in a parentheses, I can say f of x plus h minus f of x over h equals to 2. It feels like kind of overkill, but you certainly could do that. So your problem 59 should work similarly. I'll do 60, and on the next page I'll do your problem because it's a little bit harder. So as I go to do 60, first thing I need to do is find the difference quotient, which is f of x plus h minus f of x over h. And just like I did in problem 58, the first step was to create 2 parentheses in the numerator separated by the minus sign. I took the easy way out first. The easy way out is to replace that f of x symbol with what it's equal to, which is 5x plus 4. So in the first parentheses, I'm changing the f of x symbol to what it's equal to. When I go to do the second parentheses, I need to replace the f of x plus h with something. And to figure out what to replace f of x plus h with, I'm going to change the x in the f function to x plus h. So that would give me 5 times x plus h plus 4. That's going to be 5 times x, which is 5x, plus 5 times h, which is plus 5h, and then plus 4. So in the f of x plus h parentheses, I'm going to put 5x plus 5h plus 4. Now I have something that needs to be simplified. So in the numerator, I want to get rid of the both parentheses that I put forced on you. The first parentheses can be dropped without changing anything inside the parentheses. The second parentheses, the minus in front of it's going to attach to the 5x, and you'll get a minus 5x. And it's going to flip the sign in front of the 4, make that a minus 4. Almost done now, I just need to combine like terms. In the numerator, I see a 5x and a minus 5x, and those will cancel. I see a plus 4 and a minus 4, and those will cancel. The only thing in the numerator that didn't cancel was the 5h. Still haven't worked with the denominator. Now I'm set up so the denominator is going to cancel with the h in the numerator. In my answer, I'm just going to write the number 5. But you certainly could say f of x plus h minus f of x over h equals to 5. Or you could write the words difference quotient equals to 5. All right, so give 61 a go. On the next page, I'm going to do 63 because it's a little bit harder. We have 3 more problems to do. I have 12 minutes to get them done, otherwise I get another video break. So for problem 63, first step, I need to write the difference quotient down, which is f of x plus h minus f of x over h. I'm going to replace the function symbols with parentheses. For the first function symbol, the f of x, I'm going to change the inside of its parentheses to x squared plus 1. For the second parentheses, f of x plus h, I need to figure out what it's equals to. And f of x plus h is what you get when you change the x in the f function to x plus h. That's going to give me x plus h squared plus 1. And as I simplify this, I get f of x plus h equals to x plus h times x plus h plus 1. And this I'm going to need to FOIL. Firsts are going to be x times x, which is x squared. Outers are x times h, and I'm just going to write x times h. There's an implied 1 in front of that would be nice to write. Inners are h times x, and instead of writing h times x, I'm going to write x times h because multiplication is commutative. And for the inners, this h times x, which is same as x times h, I'm going to put another 1 in front of it. And the last are going to be h times h, and that's plus an h squared. So this is the foiling part. Still have the plus 1 out front. Now I'm going to, before I dump something into that parentheses, simplify this. By simplifying, I'm just going to combine the 1xh's. I'm going to leave the x squared here. 1xh plus 1xh is 2xh. I'm going to leave the h squared. And I'm going to leave the plus 1. In the parentheses for f of x plus h, I'm going to write that messy mess there of x squared plus 2xh plus h squared plus 1. So that's my difference quotient. Now I'm going to clean this up by simplifying. First parentheses, I can just drop and not change any sign inside the parentheses. Second parentheses, the minus is going to attach to the x squared, and I'll get a minus x squared. and the minus is going to flip the sign in front of the 1 and make it a minus 1. So now I have a mess in the numerator, but a lot's going to cancel. This x squared and that minus x squared are opposites. They're going to cancel. This plus 1 and this minus 1 are opposites. They're going to cancel. So this whole thing is going to simplify in the numerator to have 2xh plus h squared. The denominator I still haven't done anything with. It still has an h. To simplify this in the numerator, I'm going to do a 1 parentheses factoring. So I'm going to factor that numerator, and on either side of the plus sign in the numerator, both terms have an h. I'm going to factor out an h to the first power in the numerator. When I take an h to the first power away from the 2xh, I just have the 2x left over. When I take an h away from the h squared, it started off with 2 h's. I took one of them away, so I'm left with 1h. And now I can cancel the h in front of the parentheses with the h in the denominator. That makes it so I don't need to write a fraction anymore. And I'm about ready to write my answer. My answer is just going to be the numerator. I don't really need to put it in a parentheses anymore, but it would be okay. And I don't really need to write the f of x plus h minus f of x over h all next to it. So that would be a kind of a perfect answer for problem 63. In the next few problems, I'm going to need the very first bit of work I'm going to do here. When I started doing this work, this part of it, the x plus h squared, that I figured out using foiling, I'm going to need for the next two problems. And so I'm going to lift what x plus h squared is equal to. If I follow my work down, ignoring this plus 1, I see that x plus h squared simplifies to be x squared plus 2xh plus h squared. I'm going to use this and not recreate x plus h squared over and over again for the next few problems. So I'm going to do 64, and for 64, the function is x squared plus 3x plus 5, and I need to find f of x plus h minus f of x over h. To do that, I'm going to form a fraction that has a minus sign in the numerator, and on either side of that minus sign, I need to fill it up with stuff that's fitting the problem. For the f of x, I'm going to change that parentheses to x squared plus 3x plus 5. And for the f of x plus h, I'm going to do the algebra to figure it out. To figure out what to replace the first parentheses with, I need to figure out what f of x plus h is. F of x plus h is what you get when you change those two x's to x plus h. So it's going to be x plus h squared plus 3 times x plus h plus 5. As I go to simplify this, the first parentheses, x plus h squared, equals x squared plus 2xh plus h squared. For the second parentheses, I'm going to multiply 3 times x and get plus 3x, and 3 times h and get plus 3h. And I'm going to carry down the plus 5. The first parentheses needs to have this long mess, and I'm not sure I can fit it in here. Let me just recalibrate and give myself some more room here. So I'm taking the line that's above it and leaving myself room in the first parentheses to write this mess of x squared plus 2xh plus h squared plus 3x plus 3h plus 5. That's what the difference quotient is, but it's not simplified. When I go to simplify this, I'm going to clean up my parentheses in the numerator. The first parentheses I can just drop and leave myself the x squared plus 2xh plus h squared plus 3x plus 3h plus 5. Second parentheses, the minus is going to attach to the x squared and get a minus x squared. It's going to flip the sign on the 3x and give you a minus 3x. And it's going to flip the sign on the 5 and give you a minus 5. Lots of stuff generally cancels when you do this. This x squared and that minus x squared cancel. Plus 3x minus 3x cancel. Plus 5 minus 5 cancels. What doesn't cancel in the numerator, I'll write on my next line, which is a 2xh plus an h squared plus a 3h. Still haven't done anything with the denominator. Cleaned up the numerator quite a bit. Now I'm going to pull out a common factor of h from the numerator. And when I take an h away from each of the three pieces, I'll be left with 2x when taking the h away from there. 1h taking the h from there, and plus 3 taking the h from the 3h. Now the h's are going to cancel, which will make it so I don't need to write a fraction anymore. For number 64, my answer, the difference quotient is going to be 2x plus h plus 3. So give 65 a go. And on the next page, I'll do your 67, and that'd be the very last problem for this section. Alright, so 67. I need to figure out what f of x plus h minus f of x over h is. And that's going to be parentheses over h. For the f of x parentheses, I'm going to put x squared minus 5x plus 8. So the second parentheses, I get an x squared minus 5x. I should just give myself more room. Sorry. For the f of x parentheses, I'm going to put an x squared minus 5x plus 8. For the h, I'm going to leave it an h. And then for the f of x plus h parentheses, I need to figure out what it is. F of x plus h is what you get when you change those two x's to x plus h. So I'm going to get x plus h quantity squared minus 5 times x plus h plus 8. Borrowing from the sheet that I knew I was going to need, for the x plus h quantity squared, for this I'm going to put x squared plus 2xh plus h squared. Next parentheses, I go minus 5 times x, which is minus 5x, minus 5 times h, which is minus 5h, bring down the plus 8. That's what's going to go in my first parenthesis. So this I'm going to transfer to here and get x squared plus 2xh plus h squared minus 5x minus 5h minus 8. Now I'm going to drop the parentheses. First parentheses, I'm just going to leave it completely intact without the parentheses, but no changes are done there. Second parentheses, I get a minus in front of the x squared. The minus flips the sign in front of the 5x to a positive 5x. The minus flips the sign in front of the 8 to a minus 8. Now I'm going to cancel away. This x squared and that minus x squared cancel. This minus 5x and this positive 5x cancel. And there's a mistake here somewhere. Did it again. This right here was supposed to be a plus 8. I wrote a minus 8. The second time I did this, this should be a plus 8. Everything that doesn't have an h should cancel. And for whatever reason, I am having issues dragging down my signs. I don't know why I did, but I did. That should be a plus 8 there. And this plus 8 that I recalibrated should cancel with that minus 8. That's going to leave me in the numerator with 2xh plus h squared minus 5h. And in the denominator, I just have a solo h. I'm going to factor out an h from the numerator. When I take an h away from the 2xh, I'm left with a 2x. When I take away an h from the h squared, I'm left with an h. And when I take an h away from the minus 5h, I'm left with a minus 5. When I pull out that common factor of h, I can cancel it, make the fraction go away. My answer won't need to be a fraction. My number 67 answer is going to be what's left after I do the canceling, which is 2x plus h minus 5. All right, so that's the end of this section, and we'll just kind of keep plodding along.